Hi students, welcome to another short video on our Small Steps Good Grade Secondary Science program. Today we are going to do my favorite topic, magnetism and electromagnetism. We are going to go through some GCE O-levels physics questions. Before I jump into the questions, I would like to let you know that for this chapter, please take note that you have two important rules. One will be the right-hand corkscrew rule, and the other one will be the Fleming's left-hand rule. So the Fleming's is for the left hand, and we have the right hand, which is the corkscrew rule. Okay, so we have the screw. Okay, do remember the screw go round, and this is for the right hand. Okay, so when do we use the Fleming's left-hand rule and when do we use the right-hand corkscrew rule? When you see a magnetic field diagrams that has this design that is round, and round, we use the right-hand rule, all right? And Fleming start with the word F. So whenever the question asks for the direction of the force, you use the Fleming left-hand rule, all right? So with that, let's move on to the question. A wire carries a current and hangs vertically. So the diagram shows the magnetic field around the wire when viewed above. So let's say this is the wire and you view it above, okay? So does this question has anything got to do with force? Did they ask you the direction of the force? Did the wire move? No, right? So this is clearly on the right-hand corkscrew rule, all right? So the right-hand corkscrew rule, you have to take out your right hand. I go through in another video, how do we use the right-hand rule to look at the direction of the current, whether it's up or it's down. Please refer to the other video if you have not watched it yet, to really build on your foundation before coming to this video where we go through real O-levels questions, okay? So let's see what the questions want us to do. The poles of the magnet are placed on the either side, and what is the force now? So for this question, we have to make use of the Fleming's left-hand rule, okay? So first, let's find out from the corkscrew rule what is the direction of the current, okay? So put the right hand in front of you, okay? And you try to make an angle and you see, okay? Imagine that this is the wire looking at you, and then you take a look. Is it this way or is it this way? It looks like it is pointing downwards, and then I will have the same clockwise direction. So the direction of the current is actually downwards, okay? Downwards. So let's move on. Now, when we use Fleming's left-hand rule, we have these three, okay? So remember, father, mother, child, okay? Father is the direction of the force, father F. So mother is the direction of the magnetic field, and the last one, the child, is the direction of the current. So we know that the direction of the current is actually downwards or into the paper. Now, what is the direction of the magnetic field? So the magnetic field always move from the north to the south. So it's this way, and you have the current. You put the current into the paper, so you will have your direction of the force downwards. Okay, so you have to try it yourself. Okay, so try it while looking at the picture. So first, you don't know the direction of the force, is fine, and then you move the direction of the magnetic field. So from the north, so my north is here, my south is here. So I point this way, and then I have the current. The current is into the paper. So I have it. My force is pointing down. So the answer is C. Yes. So by using the right-hand grid rule or the corkscrew rule, you can deduce that the current is flowing into the paper. And then using the Fleming's left-hand rule, you can deduce that the current is downwards. Now, a steel rod is magnetized using a solenoid. Which diagram shows the most effective way? You can see this different. This is a direct, like a battery cell, and this curly thing is actually the AC. AC means alternating current, means sometimes the current will flow this way. Sometimes the current will flow this way. So one round this way, then the second round is the other way, okay? It's alternating, okay? To magnetize a magnetic bar or a magnetic rod, please use a direct current, okay? So when you want to demagnetize it, you use a alternating current, because for a direct current, the magnetic field is always in one single direction. So all the dipoles in the magnetic material will be pointing in one direction. So we will have a north pole in a certain direction and a south pole in a certain direction. So if you want to demagnetize it, you want to make the dipoles go randomly arranged. So you actually put a bar inside a solenoid of an AC circuit, and you slowly pull it out so that the dipoles will be irregularly arranged and you don't have a north pole and a south pole on either of the side. All right, so B and D are ridiculous. I don't know why they put the bar outside the solenoid, so it's definitely wrong. So it's either C or A. Like what I say, if you want to magnetize it, we use a DC circuit. So the answer is A. And the most effective way to magnetize a steel rod is to insert the rod into a solenoid using a direct current, only in one direction. Now, which diagram shows the direction of the force that is produced by current I in a magnetic field? So you have to go through every one of them to see whether each of them makes sense. So let me go through A, and then I will show you the correct answer, okay? So A, for this, right, we have the word force, so it's left-hand rule, okay? So you have the direction of the current downwards, and you have the north to the south pole, and my force should be pointing towards me. However, for A, right, you will realize that the direction of the force is the same as the direction of the magnetic field. So definitely this is out. A is definitely out, okay? Let's take a look at B, all right? So you will realize that the direction of the current, father, mother, child, the current is going up, and the magnetic field, so is from this way, okay? It's from the north to the south, and my force is going to the right, so the answer is D. All right, try it for yourself, because when you see me doing this, okay, you can actually imitate me and see whether you can get the direction on your side, okay? Direction of the force can be deduced by using the Fleming's left-hand rule. And I think this is the last question. So a wire carrying a direct current is positioned between the poles of a permanent magnet. So for north to south, this is the direction of the magnetic field, okay, which is your second finger, okay? The direction of the current will be your third finger, which is pointing away from you, okay? And then the north is this way. So can you see where is the direction of my force? The direction of my force is downwards, okay? So let's see what the question wants us to do. On the figure, draw an arrow to show the direction of the force acting for the current indicated. Yeah, see, the direction is downwards. Okay, so go practice your Fleming's left-hand rule, and this chapter will be very easy for you. Now, suggest two ways to increase the magnitude of the force. The magnitude of the force is determined by first, the magnitude of the force is first determined by the magnitude of the magnetic field. So you can use a stronger magnet, or you can increase the current. All right. So increase the current or increase the magnetic field by replacing the magnet with a stronger magnet. The last one, the real last. A coil of ABCD is connected to a battery. So they didn't tell you what is the direction of the current, but we should know that the convention currents actually flows from the positive terminal. So it comes out from here, the positive terminal. So this one is the direction of the current. And this, let me use a different color. This is the direction of the magnetic field. So I believe these questions want us to find out what is the direction of the force on this rod AB or on this rod CD. Okay. So one rod should move up and the other one down. Hence, this whole ABCD can actually turn clockwise or anti-clockwise. So let's try. So for this, right, the current is actually moving upwards. Okay, so Fleming's left-hand rule, the current is moving upwards. So you can point this way. And then the magnetic field is from the north to the south. Okay, so the force on AB, let me use a different color. The force on AB is actually, this is the force, is actually downwards. Okay, so this is the force. Now for the rod CD, right, the direction of the current is actually this way. So the direction of the current is this way, pointing towards you. The magnetic field is still from the north to the south. And then the direction of, you see, is pointing upwards, okay? So the direction of the force is pointing upwards. So this one is the direction of the force. So you will realize that this is turning this direction because this CD is going up and then this AB is going down. So this coil of wire ABCD is actually turning this direction, which is anti-clockwise. All right. So this is a very common exam questions. Please make sure you know how to identify and do this, and you will be able to score. So let's move on. So they ask you to draw an arrow to show the direction of the convention current, which I already did, and also draw arrows to show the direction of the force, which Mrs. Chu also did. So let's take a look at the answer. This is the direction of the current. So this is the direction of the current here, but they ask you to draw in this section, which is, so you draw in this section, and this is the direction of the force downwards. This is the direction of the force upwards. All right. So that's it. Thank you for watching today's video, and see you in the next one. Bye bye.